topic of this video is MyMathLab Problem 3.3.75. The cost of renting a car for a day is given by the linear function c of x equals 0.05x plus 30, where c of x is in dollars and x is the number of miles driven. Part A, find the cost of driving the car 175 miles. Part B, graph c of x equals 0.05x plus 30. Part C, how can you tell from the graph of c of x that, as the number of miles driven increases, the total cost increases also? Okay, let's go ahead and begin. With a problem like this, the very first thing you always want to do is you want to identify what do the variable parts of your equation represent in words. For example, we are told that c of x is in dollars. So if we wanted to, we could rearrange our equation so that it says dollars equals. The next thing we're told is that x is the number of miles. So anywhere we see x, we can put miles. 0.05 times miles plus 30. This makes clear to us that when we rent a car, the amount of dollars we have to pay depends on the number of miles we drive the car. You take the number of miles you're driving the car, multiply it by 0.05, and then add 30. That's the amount of money you owe. And even if you drive the car 0 miles, 0 times 0.05 is 0. When you add 30, you'll still have to pay the $30. So this is the flat fee, the amount of money you have to pay just to rent the car. This is the add-on fee, the amount of additional money you have to pay based on how many miles you drive the car. All right, with this form of our equation, we can now easily answer these questions. Find the cost of driving the car 175 miles. So we replace miles with 175, and that tells us the number of dollars. Dollars equals 0.05 times 175 plus 30. Okay, so the next thing we need to do is multiply. What is 0.05 times 175? The answer is 8.75. And then, of course, we still have the plus 30. Adding these together gives us the final total, $38.75. This is the answer to part A of this problem. All right, let's now move on to part B. Part B says graph c of x equals 0.05x plus 30. All right, well, we know this is a linear function because it's in the form mx plus b. That's the equation that was given to us. This is the slope-intercept form of a line. So we can see that in our problem, c of x is the same as y, the slope m is 0.05, and the y-intercept b is positive 30. So when we create our graph, we're going to use our y-intercept of positive 30, and we are going to draw a line through that point. The line needs to have a slope of 0.05. Now, 0.05 is the same thing as 5 out of 100. Notice that this is like percent. 0.05 is 5%, which is 5 out of 100. All right, so this is my rise, and this is my run. So, if I start at this point, and I go up 5, and then to the right 100, I will end up at this point. And if I draw a straight line through those 2 points, this will be the graph of the function c of x. Now technically, even though I said line, this is actually a ray. It starts at this point and then goes forever away. It does not go in this direction. And the reason for that is because of what we are measuring in this particular problem. So, this 30 represents dollars. This 100 represents miles. Miles cannot be negative. You cannot drive your car a negative number of miles. And for that reason, the graph starts at this point and then travels to the right and a little bit up from there, because both the rise and the run are positive values. All right, that brings us to part C. How can you tell from the graph of c of x that as the number of miles driven increases, the total cost increases also? If we look carefully at our graph, we notice that miles are being represented by the horizontal axis. So when this says, as the number of miles driven increases, what that is telling us is that we are moving along our graph from left to right, because the number of miles is increasing. As we move from left to right, we also notice that the cost is increasing. It's very slight, but it is going up. I'll add a few more points to make that very clear. So this point, as we're traveling from left to right, the cost is going from this value, a little bit above 30, to this value, a little bit above 35. So we are experiencing an up motion for the dollars when we experience a rightward motion for the number of miles. This idea of up and right is incorporated into our slope. So the direct answer to this last question has to do with the slope of the line. We're asked to fill in the blank in this particular problem. The graph shows that the number of miles driven increases as the total cost increases because it moves blank from left to right. Well, as we see, as we move left to right, we are going up. So we would fill in the blank in that sentence with the word upward.